If f of x is a polynomial of a degree n, and n is greater than 0, then f has at least one 0 in the complex number system. Okay? So meaning it has some imaginary real solutions. Okay, that's all that means. Remember, complex number system is that a plus bi in that sense. Okay? A linear factorization theorem is if f of x is a polynomial of n and n is greater than 0, then f of x has precisely n linear factors. So we can factor it into a linear function. Okay. Remember when we factor it to like x minus 2 times x plus 2, the x minus 2 isn't that linear? Yeah. Okay. So that's what that means in that sense. All right. All right. So example 1, determine the number of zeros of the polynomial function. Okay. So let's kind of think of this for a second. F of x equals x minus 2. That's a linear function, right? So if I set that equal to 0, remember your zeros are where they cross the x-axis, right? If I set y equal to 0, how many solutions would I have? I just have one. I'd have 1, 0. And remember, our zeros are our x-intercepts, all of that. And can anyone tell me what my 0 would be? 2. X would equal 2. Because if I set x minus 2 equals 0, we would add the 2 to the other side. So that linear function would cross the x-axis at 2. All right. If it's the second degree of x squared minus 6x plus 9, if I graph that, what does that look like? A parabola, right? And a parabola has how many possible solutions? 2, right? Okay, we could have 2 x-intercepts, not necessarily. And the easy way to kind of determine that is if you have an exponent of 2, that means your max number of real solutions, right? Now, it's not necessarily going to be 2 real solutions, but that's the max number that it possibly could be, right? So we might have 2 zeros. We don't know yet, okay? Now, could I factor that one? Yeah, I could factor that. And if I can't factor, couldn't I do the quadratic formula to see if I have 2 solutions? Yeah, but let's see, can I factor this one? Yeah, what does it factor to, Nathan? X minus 3 squared, right? Good. So what is my solution? X equals 3. So now in this one, we technically only have really one real solution because it touches that 3 and goes on, right? Because this is known as a repeated 0. Okay, so we do still have 2 zeros, but it's actually the same one because it's a repeated 0. So in this case, because that exponent is even, it just touches that 3 and then turns from there. It doesn't actually go through that value. Okay. All right, third degree polynomial. Roughly we have how many answers? Huh? We have 3, right? Because my exponent is 3. My degree is 3. Okay. So how would I factor this one? Take out an x, and what would I be left with? X squared plus 4, right? So now we set them equal to 0, right? X equals 0, and then x squared plus 4 equals 0, right? So here is one solution. How would I solve the other one? Subtract the 4, so x squared equals negative 4. And then how do I get rid of the square? Square root it. So how many answers do we have? 2, we put plus or minus. What's the square root of negative 4? 2i. So in this one, we actually have one real solution, right? One real 0. And we have 2 what? 2 imaginary solutions. Okay. This one actually only crosses the x-axis how many times? Just once. Yep, just once. Okay. All right. The rational 0 test. This is what we did in algebra 2, where we found our possible rational zeros, right? And then from there we use synthetic division to see if my remainder was 0 if it goes evenly into it. Remember that? Now, to find the rational zeros, remember, we took P and divided it by Q. P represents the factors of my constant term, and Q is the factors of my leading coefficient. So then we'll take the factors of my constant and divide it by my factors of my leading coefficient. And those are going to be possible rational zeros. Will all of them be actual zeros? No, they're just possible ones for us, okay? So let's kind of look at this one. Find, if possible, rational zeros of f of x equals x cubed plus x plus 1. So right now, we could have a possible how many zeros? 3, right? Can I factor this one? No. So that's why we have to do it in this sense, okay? So I'm going to start with first, what is my constant? 1, right? So my constant is 1. So what are the factors of 1? Positive 1 and negative 1, right? Because 1 times 1 is 1, and negative 1 times negative 1 is 1, right? What is my leading coefficient here? 1. So again, that would be plus or minus 1, the factors, correct? So now, my possible rational roots, or rational zero, sorry, is P divided by Q, right? So my constant is my P, my leading coefficient is my Q. So I'm going to take my P's, which is just plus or minus 1, and divide it by my Q, which is what? Plus or minus 1. So my possible rational zeros is plus or minus 1. Now, which one actually, what is my actual answer? Which is the only one that would allow that to work? Well, let's try. Right, we can do it 2 ways. One, we can either do synthetic division to see if my remainder is 0, or can we plug them in and see which one gets you to 0? Yeah, it doesn't really matter. Which one do you guys want to try? We're going to do synthetic, so let's just do synthetic here for a second, okay? So what are my coefficients of my polynomial? 1, x squared would be 0, x, 1, and 1. And then do you guys want to try 1 or negative 1? 1? All right, so we bring down the first, right? So it's 1 times 1? 1. Add? 1. 1 times 1? 1. Add? No. 2. 1 times 2? 2. And 3. So is 1 actual 0? No. So now we'd actually have to try negative 1, right? I'm just going to erase that. If you guys okay with that? Negative 1. So bring down the 1. Negative 1 times 1. Negative 1. 0 plus negative 1. Negative 1 times negative 1. 1. 1 plus 1. Negative 1 times 2. Negative 2. And when you add, negative 2, do I get 0? So actually, does this one have a real root? No. Real possible 0. So in these ones, we probably have an imaginary root. Did I do math wrong? No, okay. Yeah. Yeah, I don't remember off the top. If it's a graphing calculator, I can tell you. For the table ones, I'm not 100% sure. Yeah. All right. Example 3. Find the rational zeros of f of x equals x to the 4th minus x cubed plus x squared minus 3x minus 6. Okay. All right, so again, what is my constant here? Negative 6. So what are the factors of negative 6? Plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. What's my leading coefficient? 1, and that factor is just plus or minus 1, right? So to find my possible rational roots, or rational zeros, same thing, okay? We take P divided by Q, right? The nice thing is because my Q is all over 1, so really what are my possible roots? 1, 2, 3, and 6. Because 1 divided by 1, 1. 2 divided by 1, 2. 3 divided by 1, 6 divided by 1, right? All right. Now, we're going to use synthetic division to see where our remainder is 0. What are the first numbers you should always try? I'd always do 1 or -1, right? So since our last two are negative, right? Last two negatives, I'm going to try -1 here, okay? Because a negative times a negative will give me a positive, because wouldn't I want this number to be a +6 to get to 0? So that's why I pick a negative on this sense, okay? All right, so let's bring the first one down. What's -1 times 1? -1. -1 times -1, or plus, sorry, -2. -1 times -2, 2. 1 plus 2, 3. -1 times 3, -3 plus -3, -6. And what's -1 times -1? 6. And we get 0. So is -1 a real 0? Yes. X equals -1 is a 0. Okay. Now, how many possible zeros do we have? We have 4, right? So we got to try another one, right? Now, from that, I'm just going to use what we have here. So you could do this 2 ways. First, what I always try to do, can I factor this? So 1 would be actually 1x cubed minus 2x squared plus 3x minus 6. Can I factor that? Could I factor that problem? The polynomial, right? Could I factor by grouping? Yeah, I could factor by grouping. Let's see if that I could actually factor by grouping. I don't know if I can, but let's try. What's my GCF of x cubed minus 2x squared? X squared, right? What would be left over? X minus 2, right? What could I factor out of 3x minus 6? A 3, right? And what would I be left with? X minus 2, right? So isn't this x minus 2 times x squared plus 3x? Is that correct? I don't know why I put a 3 there. X minus 2 times x squared plus 3. Is that factored? So now, could you set each part of those equal to 0 and solve? Yeah. So x minus 2 equals 0. So what is my other real root? 2. Would I get a real root with x squared plus 3? No. Why? -3 and then take the square root of negative. You can't do, right? So what are my 2 real rational roots, zeros? -1 and 2. Now, could I have kept plugging these numbers in and using synthetic division the whole time? Yes. Okay. I think it's easier to see, can I factor that first? And if I can factor it, I like setting those equal to 0 and going. Okay. Now, if you use synthetic division, okay, I would use these coefficients here. And then because I have 2 and a 6, I probably would have picked the 2 next anyways, but, or a 1 again. Okay. All right, let's go to example 4. Find all rational roots. Now, real quick, the reason why I didn't use 3i in that sense, because if 3i plus or minus 3i, those aren't rational numbers, are they? They're imaginary numbers. They're not real, okay? That's why the answer was only 2 and -1, okay? All All right, so let's look at our possible rational roots. What is my constant here? 3, right? So what are my factors of 3? Plus or minus 1 and plus or minus 1 and plus or minus 3. What's my leading coefficient? 2. So I have plus or minus 1 and plus or minus 2, right? So my possible rational zeros, I'm going to take the constant and divide it by the leading coefficient. So what's 1 divided by 1? 1. And what's 1 divided by 2? 1/2, right? Do I have another factor of my constant? Yeah, the 3. So then I go 3 divided by 1 is 3. And then what's 3 divided by 2? 3 over 2. Okay, you guys okay with that? Now, as I look at this one, what's probably the least one I would ever try? 3/2 and 1/2, right? I'd start with 1 and -1, and then I do the 3s. Let's go ahead and write down my constants here, okay? So we have 2, 3, -8, and 3. So always try 1 or -1. Which one do you guys want to try first, 1 or -1? 1, all right. Because we have the negative before the positive at the end, which would give us a negative, right? All right, so let's bring down our 2. All right, what is 1 times 2? 2. What's 3 plus 2? 5. What's 1 times 5? 5. What's -8 times 5? -3. What's 1 times -3? 3. And what's 3 plus 3? 0. So is 1 a real possible solution? Yep. So x equals 1. That's possible. 1. All right, now we have a trinomial here. So before I just keep plugging in numbers, can I see about factoring that? Yeah, I would always try to factor if I can first. All right, so let's go ahead and try to factor. So this would actually be 2x squared plus 5x minus 3, right? Is everyone okay with that? All right, so can I factor 2x squared plus 5x minus 3? Yeah, we can, right? And an easy way to determine if you can factor it, what's 2 times -3? -6. Can I find factors that multiply to be -6 that add to be a +5? Yeah, so you know we'll factor if you can say yes to that. Well, 2 is prime, so we know it's going to be 2x and x. 3 is prime too, right? So we know we're going to use 3 and 1, but where does the 3 and the 1 go? 1 has to be negative, 1 has to be positive, right? The 3 goes with the x, the 1 goes with the 2x. Now, which one's negative, the 1 or the 3? -1 and +3, right? Now, can I set these equal and solve for 0? Will I get real rational roots on this one? Yeah. And what do I get? 1/2 and -3. Good. So x would equal 1/2 and x would equal -3. So in this case, you actually have 3 real roots. So my S curve, right, will cross the x-axis at 3 different places. Okay. All right. Example 5. Actually, most of these we're doing the exact same thing every time. Okay. All right, find all real solutions. Okay, find all real solutions. All right, so what is my constant here? -12. So we have lots of factors for this one, don't we? What's 12? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus, and plus or minus 12. My leading coefficient is -10. So plus or minus 1 plus or minus 2 plus or minus 5 and plus or minus 10. So my possible ones will be 1 over 1, which is just 1. 1 over 2, which is 1/2. 1 over 5. And then 1 over 10. Then you'd have to do the 2 over everything, the 3 over everything, the 4 over everything, the 6 over everything, and the 12 over everything. So we have lots and lots and lots of possible solutions, right? There is a shortcut. And this way, okay, if that happens, on a test, I'm not going to do that to you because we don't have graphing calculators in this one. The second way is actually, okay, for homework, things like that, if you have all those possibles, I want you to use Desmos.com. Okay, so if you have your computers, go ahead, or you don't have to pull it all. I'm throwing everything. So I'm going to go to Desmos.com and I'm going to show you a short way here. Okay, so Desmos, right.com, and I'm going to put /graphing calculator. Okay. And then I'm going to type in that function, which was negative 10x cubed. Plus 15x squared plus 16x minus 12. All right, you guys see that? Now, if you notice, where does that cross the x-axis? At a whole number, right? Let's make it easy. What's the whole number? Where does that cross? 2. Yep, at 2. You look, everything else is kind of in between something. We don't know exactly where, right? Ooh. Why are you going crazy on me? There you go. So 2 is the only time that it crosses evenly, right? So what's the one rational root I'm going to use? 2. So let's go ahead and use 2. All right, so back to this. All right. So do I need to write out all of those possible roots, or are we okay with that? Okay, so let's try 2. So the outside is going to be 2, because we know that's a real root already. So one of our roots is going to be a positive 2, because we saw that within our problem, right? Okay. So this is a 2 on the outside if you can't read it. All right, now let's do our coefficients: negative 10, 15, 16, negative 12. So let's bring down that negative 10. What's 2 times negative 10? Negative 20. Add, what's 15 plus negative 20? Negative, right? What's 2 times negative 5? Negative 10. 16 plus negative 10? 6. And 2 times 6? 12. And do we get 0? Yes. Okay. So now we have negative 10x squared minus 5x plus 0. Now, as we looked at that Desmos, we know those other 2 values are not whole numbers, are they? So can I factor that? No. So what's the only way we can solve quadratics if you can't factor it? Quadratic formula. So can we do the quadratic formula? Yep. We're going to go ahead and do the quadratic formula now. X equals negative b. What's my b? Negative 5. Plus or minus the square root of b squared. What's my b? Minus 4 times a. Negative 10 times c. 6 all over 2 times a, which is negative 10. All right, what's a negative and a negative? Positive. All right, negative 5 squared is 25. All right, now a negative times a positive is going to be a negative times a negative times a positive is going to be a positive. So we're going to take 25 plus whatever that addition is, right? So what is 4 times 10? 40. What's 40 times 6? 240. And what's 240 plus 25? 265. Over, what's 2 times negative 10? Negative 20. Now, is 265 a perfect square? No, it's not. Is there a perfect square that goes into 265? No, there's not. It's like 5 and something. 5 times what is that? Something, I don't know. So now, can we use our calculator and get our decimals? Yeah. Can you take 5 plus the square root of 65 in your calculator? Yeah, go ahead and do that. What's 5 plus the square root of 65? Huh? All right, divided by negative 20. So 5 plus the square root of 65 equals, and then divided by negative 20. And what do we get? Got a negative 1.06. Was that one right? No. Was it 0.564? Huh? Did you not hit equals after you added and subtracted? All right. So 5 plus the square root of 265 equals, then divided by negative 20. Do we get it this time? Okay. Huh? Okay. And then you do 5 minus the square root of 265 divided by negative 20. Okay. And you should get 0.564 for that. So we have one real, actually, we have 3 real ones, don't we? Okay. But these 2 obviously are not whole numbers in that sense, are they? No. Okay. So if you come across one that has like tons and tons of rational roots, possible rational roots, go to decimals.com and graph it, and then find the real one from that. All right. Make it easy on yourself. All right. Any questions on that? All right. Conjugate pairs. Do we know what conjugate pairs again are? If I have 1 minus I, what's its conjugate? 1 plus I. If we have 2 minus 3i, its conjugate would be 2 plus 3i, right? Okay, so the conjugate just changes the sign in the middle of it. Okay. Now, we're going to use those conjugates when we're writing our actual roots, okay, whether they're real or whether they're imaginary, all right? Okay, so if we have find the 4th degree polynomial function f with real coefficients that have -1, -1, and 3i as zeros, okay? Now, we can do, you guys know how to write -1 and -1 as a polynomial, don't you? If we know a solution is -1, if I plug that into a polynomial or an equation, what would it be? X plus 1, right? You guys okay with that? Now, normally our equation would be like start with y equals a times the x plus 1 times the x plus 1, things like that. In this case, we're just going to let a equal 1. And the reason why I'm going to let a equal 1 in this sense is because they don't give us any other pairs on my graph. They only give us our actual zeros. That's it. So I'm not going to worry about that. All right. Now, remember, to get 3i, didn't we have to have like x squared plus a number to get us 3i, x squared plus 9 to get us that number? Okay, so in this case, what we do is we're going to take x minus 3i and x what? Plus 3i. Because the only way to get the i's is if they're opposites. Aren't these my conjugates? A -3i and a +3i, aren't those conjugates of each other? So when we write our equations with imaginary roots, we have to use our conjugate. Sorry, I was going to spell that wrong for a second. Our conjugate. Now, we know A is 1 in this sense, right? So I'm going to get rid of that. Could I multiply all of that out to get our fourth root? Yeah. Which are the easiest ones to multiply by? These ones first, right? What's A plus 1 times A plus 1? Wouldn't I just FOIL it? So I'd get x squared plus 2x plus 1, right? Now over here, because they're conjugates, remember to get, honestly, if we had that root of 3i, wasn't that x squared plus 9 that would give us that 3i? Because I would subtract the 9 over, and then how do I get rid of a square? Square root, right? And isn't the square root of negative 9 the 3i? Yeah, so that's why these are actually conjugates of each other. So let's go ahead and FOIL. Now, if they're conjugates, do we have to FOIL the whole thing? No, we just multiply the first and the last. So x times x, x squared. And what's negative 3i times 3i? Negative 9i squared, so positive 9. Hey, that's how we got the x squared plus 9 from it, actually. Now, can we multiply these? Yes, we can multiply these. I'm going to go ahead and do x squared first. What's x squared times x squared? X to the fourth. What's x squared times 2x? 2x cubed. X squared times 1? Squared. And now we have to multiply the 9 to everything, right? What's 9 times x squared? 9x squared. 9 times 2x? 10x. And 9 times 1? 9. And then do we have any like terms? Yeah, the x squared and 9x squared. And what do we get? 10x squared plus 18x plus 9. All right. Do we have a fourth degree polynomial here? Yes. What are my zeros? What are my rational zeros? Not possible. What are my rational zeros? Negative 1, right? And it's happened actually twice, doesn't it? And we didn't even have to do anything because it was given to us. Do we have imaginary roots? Yep, we have 3i, right? All right. So example 7. All right, this one's a little bit more challenging here, okay? And the reason being is because A, it gives us this f of 1 equals 3, right? So doesn't that give me a coordinate? F of 1 equals 3 is a coordinate of what? What comma what? 1 comma 3. So our A can't be 1 in this case. We're going to have to plug that in, right? B, they give us 1 real root and 1 imaginary root, right? 1 real root and 1 imaginary root. Okay. All right, so my real root, let's go ahead. First, I'm going to put y equals A. If my real root is 2, what would it go in the parentheses? X minus 2. Good. All right, now for my imaginary roots, we're always going to put x minus, but now we have to put in our conjugate here. The actual imaginary and its conjugate. So 1 minus I will go in one of them. And what's its conjugate? 1 plus I. The reason why it's always x minus, because when you solve it to the other side, right, usually we have it as a minus sign, and then you add it to the other side. Remember, our roots are actually like the x minus k, where it's your opposite of it. That's why it's always minus, okay? So now, I'm going to go ahead and leave y equals a, x minus 2. I'm going to simplify this up a little bit, okay? X minus the quantity of 1 minus I, isn't that the same thing as x minus 1 plus I? X minus 1 plus I. And then x minus the quantity of 1 minus I, isn't that the same thing as x minus 1 minus I? Is that the same thing? Yes. Okay. So I distributed the negative. I just put the parentheses around different parts, right? Why do you think I put the x minus 1s in parentheses here? Why do you think I put the x minus 1s in parentheses here? If we look at this, isn't this x minus 1? And then we have a plus I, and we have a minus I. Isn't these things conjugates of each other? Since that first term is the same, and then that last term, they're opposites of each other? Yeah. So when I go to actually multiply this out, I'm just going to multiply my first terms and my last terms. I don't have to FOIL that whole thing out, do I? I just have to multiply the first terms and the last terms. So let's go ahead and do that part first. So we have y equals a times x minus 2. All right. So what's x minus 1 times x minus 1? It's x minus 1 times x minus 1. Isn't that just x minus 1 squared? Yeah, which we'll do that math here in a second because you know how to do that. And then what's I times negative I? What's I times negative I? Negative I squared, which becomes what? Plus 1. Now, can I go ahead and multiply all this out if I really wanted to? Yep. Okay. So y equals a times x minus 2. What's x minus 1 squared? Isn't that x squared minus 2x plus 1? Then we have the plus 1. So then now what do you notice? Do we have like terms inside that second parenthesis? Yeah. So I'd have x squared minus 2x plus 2. You guys okay with that? Now we can do this two ways, A, we can either multiply these two out, or B, we can go ahead and find A first before I actually do all that multiplication. So do you guys want to go ahead and find A first, or go ahead and just keep multiplying first? It's up to you. Anyone? You guys want to find A first or last? Honestly, it really doesn't matter. Find A first? Okay. If we're going to find A, we have to plug in the point 1 and 3. Where will 1 go into? The x. And where will 3 go into? The y. So I'm going to have 3 equals A times 1 minus 2, right? What's 1 minus 2? Negative 1. All right. Times, what's 1 squared? 1. 2 times 1? Plus 2. So what's 1 minus 2 plus 2? Yeah, so isn't that minus? That's why I have minus 2. Yeah, sorry. So what's 1 minus 2 plus 2? 1. And then what's negative 1 times 1? Negative 1a. And then so a would equal negative 3, right? So now I have y equals negative 3 times x minus 2 times x squared minus 2x plus 2. So now we got to finish writing our equation, don't we? Whew. So you got to multiply and then distribute a negative 3 through, right? Can we do that? Yes, I think we can. I'm running out of room though. Let's see if I can do this. Need more room. There we go. All right. right, so let's go ahead and multiply these two first. What's x times x squared? X cubed. X times negative 2x? Negative 2x squared. What's x times 2? 2x, right? All right, let's do the negative 2. What's negative 2 times x squared? Negative 2x squared. What's negative 2 times negative 2x? 4x. And what's negative 2 times 2? Negative 4. And I wrote it this way just to kind of help me keep it organized. So then we have x cubed. What's negative 2x squared plus a negative 2x squared? Negative 4x squared. 2x plus 4x? 6x, and then minus 4. And then what do we need to do from here? Distribute. So we get negative 3x cubed plus 12x squared minus 18x plus 12 equals y. And there is my cubic function. Whew, that took a long time, didn't it? All right. All right, every factors of a polynomial. There we go. Every polynomial of n of degree, yeah. Every polynomial of n of degree n is greater than 0 with real coefficients can be written as the product of a linear and quadratic factors with real coefficients. Okay. We're going to do pretty much, honestly, guys, it just means the same thing as we've been doing, okay? So we're going to find our possible zeros or find all the zeros given an imaginary root first, okay? So if we're given an imaginary root, do we know how to find factors of that? By using its conjugate, FOILing it out, right? Once we do that, can we then divide the polynomials? Yep, to make sure we can get more factors of it, okay? So find all zeros of f of x equals x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. Given that 1 plus 3i is a 0, okay, of f of x. All right, so since this is a 0, we can find the actual polynomial that goes into the original polynomial, right? Okay. So 3 plus 3i. So if I put that in our quantity, remember it's x minus the roots, and we always have to use its conjugate, right? So if my 1, 0 is 1 plus 3i, what would be the other one? 1 minus 3i. Okay. So if I have x minus the quantity of 1 plus 3i, can't I rewrite that as x minus 1 minus 3i? And then the second one, I could have x minus 1 plus 3i. You guys okay with that? And now, since they're conjugates of each other, since our first terms are the same and our last terms are the same, we only need to multiply the first terms and by last terms. So x minus 1 squared, right? X minus 1 times x minus 1 is just x minus 1 squared. Okay. And then what's a negative 3i times a positive 3i? Negative 9i squared, which is just a plus 9. And then can I FOIL x minus 1 squared? Yep. And when I FOIL this, I get x squared minus 2x plus 1. And then what would I get here? X squared minus 2x plus 10. Okay, plus 10. So this trinomial will actually go into that polynomial evenly because we already know that these are our zeros, right? Those are our roots. So since we know those are our roots, this trinomial goes evenly into that polynomial. Now, if we need to find the other zeros, I need to find my other factors, right? And if I need to find my other factors, can I take this and divide it from that? Now, can I use synthetic division on this one? I can use synthetic division on this one? No, why not? Because this is a trinomial. The only way you can use synthetic division is if it's a binomial, right? This is a trinomial. So we have to use long division. Didn't we talk about long division last time? Yeah. Okay. So x to the fourth minus 3x cubed plus 6x squared plus 2x minus 60. And we're going to divide this by x squared minus 2x plus 10. All right, so x squared goes in x to the fourth how many times? X squared. And I'm going to take x squared times this trinomial, right? So I'd get x to the fourth minus 2x cubed plus 10x squared, right? And then I would subtract these. X to the fourth minus x to the fourth is cancels. Negative 3x cubed minus a negative 2x squared is negative x cubed, right? Because you would change that. The two negatives make a positive. 10x squared minus 10x squared would be a negative 4x squared. Bring down the other two. All right, now x squared times what gets me to a negative x cubed? Negative x, right? I know, I'm not going to do too much. Just double check the homework on where I changed it for online, okay, for you. We're just doing 2.5, yeah. And then, again, we need to talk sometime on like makeup and that kind of stuff for you. Or if you can come in one day, we can do it. Mm-hmm.
I get done.
Okay. Oh, so then you can come back one time maybe. Yeah. Okay. Because I do have either 8th block is pre-calc too. So yeah, and then 4th block's my algebra 1 honors, which they always have like a half hour to work on stuff. So it really doesn't matter. Just tomorrow I'm not going to be here. So maybe Monday or Tuesday. Okay. Or maybe both, depending on what we need. Okay. Have a good one. Thanks. All right. So then x squared goes into negative x cubed, negative x. So we get negative x cubed, positive 2x squared, negative 10x. And then what? Subtract. So negative x cubed minus negative x cubed is 0. Negative 4x squared minus 2x squared is negative 6x squared. 2x minus a negative 10x is 12x. And then bring down the minus 60. All right. X squared times what gets you to negative 6x squared? Negative 6. Oh, it's not responding. Negative 6. And then when I distribute a negative 6 through, what is my remainder? 0, which it should be, right? Okay. So now, up here at the numerator, this is not responding right now. We have the x squared minus x minus 6. Can you factor that? And once you factor that, those are your real zeros. Tell me my real zeros. And that's it. Okay. So what is x squared minus x minus 6? How does that factor? X plus 2 and x minus 3. So what are my two real solutions? -2 and +3, okay? Any questions with that? I know that's kind of, obviously we don't have finishing it out. We had the x squared minus x minus 6. So then I factored it to x plus 3, or excuse me, x minus 3 and x plus 2. So my real solutions would have been 3 and -2. Okay, 3 and -2. All right. So write f of x equals x to the 5th plus x cubed plus 2x squared minus 12x plus 8 as a product of linear factors and list all the zeros of the functions. Guys, linear factors, if I have x plus 1 times x plus 2, aren't each of those linear factors? Yeah. So if we're looking for our linear factors into where we can factor it, don't we need to know our possible zeros? And once we know your zeros, you can plug it into your parentheses, can't you? All right. So what is my constant? 8. What are my factors of 8? Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. What's my leading coefficient? 1, so the only factor is 1. So if I take the constant divided by my leading coefficient, aren't my possible zeros just my constant? Yeah, because 1 divided by 1 is 1, 2 divided by 1 is 2, 4 divided by 1 is 4, 8 divided by 1 is 8. So those are going to be my possible zeros. Okay? So now we're going to use synthetic division. Okay, so we have our coefficients. X to the 5th is 1. What's x to the 4th? 0. X to the 3rd, 1 squared 2, constant -12, and 8. So now, what's my easiest ones I always want to try? 1 and -1, right? Now, we want the last one to be, we need this to be 0, right? And for that to be 0, this one above it has to be a negative, right? So what kind of number times a negative would get me to a negative number? A positive or negative? A positive, right? So let's try +1. Okay, I'm going to try +1. If that doesn't work, I would try -1. If then, 1. 0 plus 1, 1. 1 times 1, 1. 1 plus 1, 2. 2 times 1, 2 plus 2, 4. 4 times 1, 4. -12 plus 4, -8. 1 times -8, -8. And when you add a 0. So good. Thank you. I was like, something's not right there. All right. Now, from there, so we know 1 is a solution. So what would it be written as a linear factor? X minus 1. Good. Okay. Now, if I write this as x to the 4th plus x cubed plus 2x squared plus 4x minus 8, can I factor a 5-term polynomial? No, so I'm going to have to use synthetic division again, okay? So we get to pick another one, okay? So I'm going to use the coefficients of 1, 1, 2, 4, and -8. Now, as I look at this one, the last few numbers are all what? What kind of numbers are all at the end? Even numbers, right? Even numbers. So I would probably now try what? I'd probably try 2, right? Do you guys want to try +2 or -2? -2. And why did you guys pick -2? Because you're already done? Yeah. Did you try -2 first or +2? +2, and that didn't work. Okay, one reason is because we need this to be negative at the end, right? Or a positive in that sense. So let's bring down the 1. What's negative 2 times 1? Negative 2. 1 plus negative 2? Negative 1. Okay. Negative 2 times negative 1? 2. What's 2 plus 2? 4. What's negative 2 times 4? Negative 8. Negative 4. And what's negative 2 times negative 4? 8. And what's negative 8 plus 8 is 0. So x equals also negative 2. So in a parenthesis, that would be what? X plus 2, right? Now we have actually a polynomial. We have x to the 3rd minus x squared plus 4x minus 4. Can we factor a 4-term polynomial? Yes, by what? Grouping, right? So what can I factor out my first ones? X squared. And I'm left with x minus 1. What can I factor out of the second group? 4, and I'm left with x minus 1, right? So we would have x squared plus 4 times what? X minus 1. And then we also have another x minus 1, which would be squared. And we have x plus 2. So there's your factored form. And which ones are my linears? The x minus 1s and the x plus 2s. So we actually have 3 reals, right? 3 real. One of them is repeated, correct? Okay. And then we have, what's the x squared plus 4? Is that real or is that going to be imaginary? It's going to be imaginary because it would be 2i, right? 2i. All right. Plus or minus 2i. All right. Any questions with that so far? All right. We will go ahead and stop for today. We'll talk.